Hi, everyone. Welcome to our second panel at Quantum Tech this afternoon. We're going to focus a bit more on driving quantum adoption within your organization and accelerating that quantum adoption. And I'm delighted to have with us to moderate the session Robert Suter of IBM. Bob has recently been named the Chief Quantum Exponent for IBM's quantum computing program, essentially evangelizing and translating the science and evolution of this highly technical area so that it can be understood and used by business people, industry analysts, influencers, students, educators, government decision makers, and the media. So Bob, I'd like to hand the floor over to you. Thank you.
Thank you very much, Amit. Before the panelists introduce themselves, I'd like to talk a little bit about the goal of this. So the title is Beyond Enterprise Adoption to Quantum Acceleration, How Can You Drive Quantum Expertise Within Your Company? You know, this is one of the most common questions we get. I'm in the IBM Quantum program, as it said, which is, you know, we can do all the Quantum 101 courses. We can teach people about quantum. We can talk about a range of technical topics, but people want to know how they get started. Maybe if they're in the C-suite, they want to say, well, who in my organization knows anything about this? I've just spent the last few years building up AI expertise. Now I have to build up quantum expertise. Do I have to hire more people? So where do you get that kernel of people in your organization who knows something about quantum, who can work within your organization, work with others perhaps to set the correct strategy, both the business strategy and the technical strategy for how you'll proceed with quantum computing? So I hope this panel sets the framework, if you will, gives you a few ideas as you attend other talks for the conference. And as you see people and you're relating this to your business, how to make quantum real for you, particularly from the expertise perspective. So I'm going to ask the panelists now to introduce themselves. I'm going to go from left to right as I see you to make my life easier. So if you would, please introduce yourself. Where do you work? What are you doing? What's your involvement with quantum? And then we'll jump into our discussion. So Florian, let's start with you.
Thank you very much for the introduction. My name is Florian Neukert. I work for Volkswagen Group. I'm responsible for an area where we basically do algorithms development along our whole value chain. And I'm part of the quantum computing group too. So the whole quantum computing group is part of that other group. But my active research, as far as I can get to it, is still quantum computing. So besides, I also work at University of Leiden, where I've been a professor for quantum computing for a couple of years now.
Thank you. Joydeep.
Thank you. Hello, everyone. So my name is Joydeep Ghosh. I'm leading the quantum computing research effort at Ford Research and Advanced Engineering. We are part of the broader artificial intelligence and machine learning team, quantum and advanced computing being part of that department. And we are actually collaborating with other teams inside Ford, understand where advanced compute can make a difference. We are having in-house research and also work with external partners.
Very good. Matthew?
Hi, everybody. Matt Versace, Senior Director of Artificial Intelligence and Cognitive Technology, as well as a Distinguished Engineer for Optum. We're the tech arm of that big UHG, big insurance behemoth out there. I'm an AI guy and kind of schooled in everything from the old AI to the new AI. And quantum was just another thing that we put in our portfolio. So I take a healthcare approach to this, and then and much more of a clinically facing approach too. So we started off the research group. Now I'm in a clinical applications group, taking AI and high tech and things like that, and applying those. The biggest change for us is we dichotomize up the constituency to producers and consumers and place ourselves very much in that consumer space of the tech. And that changes how we stand up competencies and educate folks. So that'll be the big theme of how we kind of extend our vision.
Very good. Jay Lowell from Boeing.
Hi, Jay Lowell. I'm the chief engineer for an organization called Disruptive Computing and Networks within Boeing, and that organization has the responsibility for all of Boeing's quantum technology research, which for us is a mix of research and work in quantum sensing, quantum communications and networking, and quantum computing algorithms and their application.
Very good. Okay, and for those of you who are attending, we will be keeping an eye on the chat. So if you have questions as we go along, please ask. I'll try to work them in. Otherwise, we'll take a little time at the end for your questions. But I do want to try to make this interactive. So let's roll back a little bit to the beginning of your I'll call it the quantum journey. All right. We don't have to go back to 1900. Okay, so we'll bring it up a little bit. But Florian, when did your organization really start getting interested in quantum? What inspired you to do it? And also, as you did that, what was the expertise you had locally? So was it just you? Was it a group of people? What attracted you to it, and how did you get started?
So coming from academia, or at least having still a partial life in academia, I'm always interested in applying latest research to improve a product, to make a new product. And that's also how it started with quantum computing at Volkswagen. So back in 2015, there was another guy in my department, Christian Seidel, and I were thinking, is now the time to start looking into practical applications, well knowing that we probably won't change the world today, but maybe we can take some of the applications that we are interested in and scale them down, make them smaller, and then try to embed them, run them on existing quantum chips and see if that already has some potential for the future. And we decided we'd start with one very, so it's a complicated project, traffic flow optimization, but we made some assumptions back then and abstractions. So we didn't really solve all the traffic problems in the world in 2015. But we said, if we can show that you can take a quantum chip that's available today, so back in 2015, and run this, so take some real world data of a problem that everyone within Volkswagen Group can relate to, that people in the world can understand, maybe that's the kickoff for a quantum computing group. And that was successful. And then we got our CIO excited about it, and he is very tech savvy, so he supported that endeavor. And then so piece by piece, we started building up a small quantum computing group that grew over time and now is looking into everything that everyone else is looking into, which is machine learning, optimization, and simulation.
I did notice you did not solve all the traffic problems of the world. But it was a good start. Okay, same question, Joydip. How did Ford get up and running, and you're thinking about quantum?
Yeah, so 3 years ago, I think we started our quantum journey at Ford within the responsibility at Ford Research. So the first engagement that I can talk about publicly is with NASA at that time. And we were thinking about a routing problem. So it's a combinatorial optimization problem known to be a hard problem for traditional computing. So the goal at that point was not really to solve a problem and take all the way to business, right? So we understand that it's more like a research exercise. You have to cross barriers, and then at some point you will develop sufficient insight, not only for the problem that you are solving, but also what type of problem you are planning to solve using the same technology. So that was kind of our internal exercise, like how exactly we can formulate the problem, what it takes to kind of solve it. When we take it all the way to some quantum hardware, we are very much in the hardware agnostic philosophy, not really tied to any particular approach, because we don't want to predict here that who is going to be winner and who is not going to win. So that's how we started. But later on, as I mentioned, that we adopted our hardware agnostic and approach agnostic philosophy. So we have done various different projects in other domains. A few examples include some near-term approaches, for example, using quantum Monte Carlo, and run it, for example, in a classical hardware. Sometimes people just call it quantum-inspired computing. There is no quantum hardware involved, but essentially you are trying to use quantum Monte Carlo and then see how much you can push essentially the classical computing before even quantum computer gets ready, right? So we have explored that area. We are also exploring the NISQ domain, the noisy intermediate scale quantum. And we are working with the university right now. And of course, working with third party because Ford is not going to create a quantum hardware. And of course, we have to work with the third party. So in the 3 years, I think we have developed sufficient insight in terms of not only about the quantum approaches, but also how exactly we can formulate the problem and how exactly we can define the hybrid version. Because every time when you go to deploy anything to the business, there are so many business rules that you have to satisfy apart from the technical conditions. It's not the job for a quantum computer alone. So it always have to be within a hybrid platform, and you define some active area and you outsource it to the quantum. And there will be some, passive area, the environment, for example, that you can handle with your classical computer. So, and this is a great learning. So this is something that we are essentially trying to learn for all different approaches. I think that's valuable. That's valuable for the industry research.
So understanding the dividing line between what you can do classically and what you hope to do with quantum. I'm on record as saying, well, quantum inspired means you're inspired to use real hardware. So, yeah.
Inspired. I don't know what inspired means. I can always say that I'm a black hole inspired person, right?
I know.
It doesn't mean anything.
I think there's a marketing person out there who knows exactly what quantum inspired means. But, Matthew, let's turn to healthcare. And how'd you get up and running?
So I think unlike my esteemed colleagues on the phone, we had no high-level support. Our CEO, CIO never came out and said, "Thou shalt do quantum." We did none of that. We came from the bottom up, totally grassroots. It was basically me being a passionate individual initially, and then trying to learn it to an extent where we could get into the game of education. I was at the university for a decade, so I know how to educate folks, and that was the route we took, was to begin educating folks in this space in our niche from our healthcare perspective and our consumer oriented perspective, which I think is a little bit different. And then we partnered. We've got this thing called Optum Tech University, Optum teaching Optum. We're a big company. We've got lots of folks around the globe, and so we have ways of teaching our technology to our technologists and sort of upskill and reskill, those kinds of things. We partnered with them and had this crazy idea that we could pull off creating our own homegrown educational vehicle. And so we launched that this year. Had folks on 3 continents, Ireland, India, and the US, and they'll graduate there in probably a week or 2 out of about 8 months worth of work. And so that's how we got started. Now our business, we're in the healthcare space, so we're not going to do the technology route like you'd see from Volkswagen or Ford or Boeing. We will have none of that. Where we'll find business justification is patents and defensive publishing. So in the quantum future, can we create enough room for us to play unimpeded in the litigation space? And that's a legitimate area for us to justify our existence. And to be honest, many of the executives didn't take us seriously initially. They're like, yeah, whatever, quantum, until we got our first patent and our first defensive publishing through. And then they started going, hey, what are you guys doing over there? And that was kind of how we went from just concept to legitimacy.
And I want to return in a little bit. I want to hear more about the internal university and internal training. But Jay, just to complete that question regarding how Boeing got up and started. As you mentioned at the introduction, there are lots of technologies that begin with the word quantum that would be applicable to Boeing. Focusing on quantum computing specifically, Where'd you get your start as an organization?
Well, actually, so we're an interesting hybrid between these two. We had our CEO came out in 2018 and went to my boss, the senior vice president, and asked him to lead up this organization, Disruptive Computing and Networks, to try to look at those areas of disruptive technology and how they would affect the aerospace industry, how they would affect us in how we build our products, how we deploy our products, how we build our products. And so, but he didn't really give a specific charter about what areas to look at within that very broad space. He said, we know there's stuff out there that we need to be paying attention to. What are those things? My boss decided we were going to focus on a few things. One of those he wanted to look into was quantum technologies, and that's when he brought me on board. And so I took a grassroots approach to figuring out what we could, should, and what we could do and what we should do. I went through, we have an internal social media network within the company, and scoured that network to find expertise. My hypothesis starting out was that we would have some number of people with training that would overlap with quantum technologies. Just by the nature of the broad work that we do, we have people who work on sensors, communications networks, electronic design. We have many different technology segments within the company. And what we saw was a lot of people who'd gotten their initial training in something that was quantum technology related, and then had gone on to work most of their career in some other area, or a portion of their career in some other area. And so we went and I basically pooled those people, and we found about a half dozen to a dozen people that we could use as a core of people who were trained in quantum, and then build from that, build on the ideas of what kinds of projects should we go work, what kind of people should we bring in to augment this small skeleton team, how should we do that training. We ended up doing a lot of what I call buddy training, where we'd have, one lead who had quantum education and 2 or 3 people who had complementary skills that the quantum trained person was bringing along and training up as they worked on the project. And so it's been an interesting kind of hybrid compared to the other approaches that we've heard. And I think it's been a relatively successful model. We now have, pretty broad support within the organization. My boss is a senior vice president within the company and reports to our chief engineer. So we have, good oversight and visibility all the way up to the C-suite on, attacking these problems and providing value to the company over a range of timescales. The sensing, then likely the computing and networking coming in after that.
I noticed you have a copy of Mike and Ike behind you.
Among other things, yes.
Among other things, yeah. Did you give everybody a copy of that and send them off?
Not quite, but we did recommend it to those people who were really focused more on the computing aspects. Those doing the sensing, obviously, there's probably a different reading selection that was involved.
Have you enlarged the quantum education beyond your initial group? So is there anything across Boeing, shall we say, as part of your standard education now that includes quantum?
We have not done anything internally. We've tended to leverage the very good courses that are out there. We've had people attend courses at the MIT education. The University of Chicago has a good education kind of certificate style program as well. And we've had people attend both of those and been very successful with that.
Going backwards, Matt, to you, let's return to your internal training. Did you also supplement that with any of the external courses, the MIT, edX, et cetera?
So yeah, what we did was our perspective what is going to be slightly different, because we look at the quantum world in 2 phases: those who produce the technology and those who consume the technology. And when you look at it through that lens, the landscape changes. Like the folks who produce the technology, their basic skill set, the skill set you teach these guys from, are dense quantum physics, opaque mathematics, and material science. And they should be, because they're creating the hardware and systems for that to work on. We don't care about any of that. That doesn't bother us. That's not our concern. We're on the consumer side. We need software engineering skills and professional consultancy skills, because our folks are going to have to talk to the C-suite, the media, business stakeholders, folks who are just learning how to spell quantum computing. And the educational materials for that come from a very different pool. From that lens, we would, we look for those materials that were slanted towards that constituency. So the O'Reilly book was good because it comes out and goes, look, we'll do a little bit of math and a little bit of quantum physics, but it's really software engineering. That was a mainstay for us. We did private label a little bit of stuff on MIT X Pro, but literally we had to invent the rest of it ourselves. So, which was basically me nights and weekends working on things off the side of my desk. And I'm happy to say I'm still married. My wife still loves me, and I'm not in divorce court. We're all good there. But it was it's a year and a half worth of heavy work, and we have internal events in Optum Tech University. That's a yearly thing. It's called Developer Days. Optum teaching Optum all these new things, and no one ever does any good work unless you put your head on the post where you're responsible for something. So, a good year and a half prior, I said, you know what, I'll do a quantum thing in the next round. And that gave me enough time to actually get everything together, work hard, have a goal, stay on a schedule, and develop these materials, which we hope to open source and just get out to the general public so the entire constituency can have a look at another way of training folks.
Good. Joy, internal training, or let's put it this way, further training of your folks. What have your approaches been?
Yeah, so we are actually part of the technical team at Ford. So there are two things. One is the skill set that you need when you're thinking of a workforce that you can engage within the technical team. So from that perspective, we are professional quantum computing practitioners, all of us in the team. For the broader company, we have some internal, mechanisms to kind of socialize. Other than that, I don't think that's doing the heavy lifting of it, because you really need something more than that. And we are also relying on those external resources, for example, the MITx or IBM or wherever the quantum certifications are. Those, on the other hand, will give you the broader idea. And then comes the question of how I can leverage this technology tailored to our needs, right? And that's where we are responsible to kind of educate the company as well in terms of the conversation procedures that we have. So these two things are needed, but of course, that when it comes to the point of research, it requires a more professional people who are actually developing this within the company.
The science and the engineering, specifically. Yeah. Florian?
Yeah, it's the same for us. So I agree with everyone. So we have our quantum computing team, and everyone in that team had a quantum computing background before they joined us. But then the whole area, the whole department is technical. So everyone is an engineer, and what we do is educate people in using different technologies. That's not only quantum computing, but also other areas such as machine learning. So if someone has a background in natural language understanding, they may also be interested in quantum computing. So we do that. And then for the bigger company, we see ourselves as a sort of seed. So we don't have the single right of use for a technology. So if we bring in a technology and we start working on it, then the idea would always be that we spread the word. And that's what we do with internal seminars, courses. It's not like giving academic lectures on quantum computing. It's really making people understand what quantum technologies in general are capable of, or what you can expect in the future. There are so many misconceptions out there. And one of the worst case scenarios would be that my CIO is on stage and says quantum computers will replace all classical computers. So that's something we want to avoid. So and the education really should go towards people being able to give an elevator pitch on quantum computing and think about the problems that they have in their areas, and think about whether quantum computing is the right tool to solve the problems, and then hopefully get back to us so we can work with them.
For our part,
it's really interesting hearing everybody else talk, but because I think unlike every other team, we're probably in the minority here in that our team is minority quantum. The quantum trained people are by far the minority of every one of the teams that I have deployed to work on various aspects of quantum technology. And I think that's been one of the things that's allowed us to be successful rapidly, is learning that not every skill must be a quantum skill. Even working on, for instance, leading our quantum computing applications team is someone who has not had a formal quantum computing training. They've worked the MIT course, but their background is a futurist. And so they're really much more adept at looking forward and thinking about how to use capabilities. And that gives them a much stronger ability to guide the team and provide guidance to that team as to how to deploy their skills. And then we augment those people that are quantum educated in that team, even with, applied mathematicians, statisticians, chemists, structural engineers, mechanical engineers. We have a wide variety of skill sets that we're bringing to the table, and the quantum people are just the tip of that team, which seems a very different model than most everyone else here.
Well, and those other people will learn more about quantum themselves.
They have, in fact, every 1 to a 1 has indicated it, because we've surveyed at the end of the year. How well do you feel you understand the project that you're working on, its goals, its objectives, what it's built on, why it's possible? And that awareness has grown dramatically over the course of time. We've even seen where the non-quantum people are actually starting to take lead and do some of the briefing and messaging and carrying the heavy load. And it's been really satisfying to see as a leader of a bunch of these teams.
For our part, just within IBM, we're a little different in the sense that we provide quantum systems. So we have a company-wide learning program called Quantum Conversations for Business. And so it's 2 hours, it's video, it's various short quizzes and things like that. And it's to give people right across the company just the barest amount so that they can understand what it is when all the rest of us are talking and what we're going from that perspective. We're now looking at advancing that in different ways. Let me get a couple of the audience questions that have come in. One question was, have you seen benefits from the internal training and education for a quantum workforce yet in terms of business applications, or is it still too soon? So let me just say at the top here that typically speaking, quantum computers are not doing better than classical computers yet. We need them to get bigger and more powerful. There are different approaches that are closer or not. But let me make that question a little bit more general so you can answer that specifically. That is how close you feel quantum is to actually doing something positive concretely in the business. How has it changed your approach? Have you changed the direction of maybe what you're doing in business because of quantum? What has surprised you about having a more quantum savvy workforce other than just for quantum itself, right, as the applications you've described? Matt, let me pick on you here.
I was secretly sitting back there going, I hope he doesn't call on me. I hope he doesn't call on me. I hope he doesn't call on me.
I could tell.
It's just written all over my face. So I think we'll be the last ones as an industry to actually do stuff on quantum hardware. It's just, healthcare, it's just kind of the way that is. We may do some optimization issues. Healthcare is a very rich space. Don't get me wrong. I think it's one of the richest spaces outside of the DoD space, and for a good reason. We've got tons of use cases and all of that. It's just a slow conservative space. But what we'll see, I think, is the aside from patents and defensive publishing, which is really geared towards allowing us, providing us latitude. The things that will change most with quantum is a event horizon that's going to affect us all. I mean, at some point in time, there'll be a legitimate threat to RSA encryption out there, and it'll be public, and all the sleepy executives out there who can't spell quantum computing yet will be awoken to it, because it's going to be a blunt traumatic event that happens to you. It's not going to be something that you go out and sort of chase because it's a wonderful opportunity out there that could be exploited for immense capital gains. It's going to be something that happens to global commerce out there. When that happens, there'll be a global awareness, and our, what we're doing is trying to preemptively prepare ourselves for that. That doesn't mean we actually have to go out and solve problems. Patents, defensive publishing will do it, but developing the code bases, developing the people out there who have these capabilities in that consumer-facing lens in the healthcare space, that we begin to identify, and we have. I mean, we've had ideation sessions about quantum throughout the entire spectrum of RX claims, R&D, drug discovery, genetics, genomics, those kinds of things, to develop the awareness and competencies and resources internally, just all the hard under the covers work that needs to be done, so that at some point in time when that event horizon hits, you can be most prepared that you can be. Now, if you're a Boeing or Ford or Volkswagen, you've got lots of cool hardware and all that kind of neat stuff, those kinds of problems that you can work on that we won't see just yet. So we're going to, in short, we're doing everything we can up until the point where we can't do any more, en route to preparing for that eventual event horizon.
Okay. Let me shift directions a little bit here. So to varying degrees, you've talked about the buy-in from, let's say, your more senior management or executives. Are there specific metrics? So what does success look like? Is it a metric? Is it a result? How will your funding keep flowing? So this is a general audience question. So here I do want to put you maybe thinking even beyond your own organization and speculate a little bit for others, how they can show that their investments in training, early explorations in quantum are actually doing some good that will eventually lead to something. So Joydeep, I want to start with you on that. So for what Ford is doing, but also give advice to other enterprises, please.
So quantum hardware is not ready yet to tackle the industry scale problems. We know that, right? Mm-hmm. So this is therefore this is really a pertinent question, that how are you going to define success that you mentioned? Well, the way we view it is we have a roadmap in general in the quantum community, and through that roadmap, we have some visibility that how the hardware is advancing to a certain goal. The question is, quantum computer is not a computer where you just plug in your problem and you get the solution out when the hardware is ready, right? You have a learning curve. So you have to prepare your problem. There's a cultural thing that you have to probably develop within the company, right? Because oftentimes there are so many business processes that are done in a big organization, you don't even know where the opportunities are. Because the people who are really involved, who are very technical, involved in those specific processes, they have a huge bandwidth for that specific problem, but they are not aware of what quantum computing can offer, or what other similar technology can offer. So the question is, if we cannot really kind of spread it out to those levels so that everyone really understand what the capability is in this technology, and think out of the box within the company in order to understand how that technology will change the way I am responsible for my business operations. So that is very much needed, right? And this is not an easy path, but coming back to the question of success, this is exactly what gets the most importance, right? Because when we do a project, we always assume that there will be a roadmap and the hardware vendors will follow that roadmap and quantum hardware will go to the right path. Question is, we are not responsible for the hardware. We are the users of those hardware. Question is, how much ready are we, or what decision are we making today in order to prepare ourselves when the hardware gets matured, right? And that is actually defining our success criteria. So oftentimes our success criteria does not indicate that the problem that we are solving, how ready that problem is in order to take it to business in few years. Rather, we are kind of viewing it, how well prepared are we in order to find use cases, convert those use cases to a very concrete problem statement, converting that problem statement to the right format so that they are amenable to a specific quantum hardware, and also make a decision that what sort of problem is more amenable to one particular quantum approach versus another. So these are the criteria that we think when we think about success at Ford.
At what level do you have to review your quantum work? Here, by the way, I'm blurring a little bit. In the sense that you're not doing quantum for quantum's sake. You're doing quantum for to help solve certain problems within your organizations. I understand that. So I'm not asking, did all your employees get 100% on the test about quantum computing? Right? I'm asking very precisely, has it helped your business? How high up do you have to go to kind of justify? Jay, you're very close to the top of the company. You talked about the chief engineer and so forth. What's the level of review? Joy, just staying with you for a moment. Is it your immediate management? Does it go much higher than that?
No, so I think the way it works at Ford Research is our CTO is a big champion for this forward-looking technology, and it's under his leadership. I think Ford RNA is Ford IT is a different organization, and they are looking at the software development kits and developing their internal workforce, preparing their internal workforce and knowledge transfer and things like that. But Ford RNA's responsibility is more towards understanding the core areas of quantum computing and how we can leverage that. And that is coming directly from our CTO. So we are kind of, almost directly supervised. Our department is kind of almost directly supervised by our CTO. And then, of course, there is a directorial structure for it. But this is an area which is important for Ford. So it is coming from more from the top down. But at the same time, this is our responsibility as well to educate the company even from bottom up, right? So that is important at the same time.
You mentioned roadmaps and such. I mean, first, let me insert a little plug. In about an hour in the conference, several of us from providers will be talking about roadmaps for quantum hardware and systems. If you want to tune back in, do you have your own internal roadmap for how quantum will engage with these different projects? I mean, explicitly for quantum, or is it more general solution roadmap?
We do. We just call it our vision. It essentially, and that vision is quite independent of the roadmaps. For a specific hardware company, for example, right? Because this is an approach which is still at its early age. So the way we develop our vision is how exactly we can define our existence and footprint for the goals that are real in the long term, at the same time not missing the near-term wins, which is why I have been talking about the areas that we are looking, which is the classical limit, right? The limit for the classical computing. You can call it quantum inspired, you can call it whatever you want, but this is an important area, because it's not only for the automotive industry, but I think as a aftershock of this entire quantum computing technology that is coming, it is pushing classical computing quite a bit, right? So we can clearly see that. And being in IBM, you know it better than I do, because the IBM has a history for it, and we all understand where it is going. But this aftershock is not only an academic revolution; it has to have an industry overlap. And there are near-term opportunities that you can procure from that, and we don't want to miss that as well. So this is how we actually develop our vision, that what exactly are the near-term wins for us, and how exactly not to miss our boat in the long shot. So that essentially defines our vision.
Okay, thank you, Florian. Let's return also to this little idea of roadmaps and measuring progress and success. Can you give us a sense of how it's done inside your organization?
Yes. So we always start with an application. So we know that for most of the applications that we develop today, it's not going to change the world. So it's not going to beat the classical algorithms that we have in place. But so Volkswagen per se defined quantum technologies as strategically important. So that makes it easier on the one hand, but still we have to deliver something. And it's easier for us to deliver in terms of use cases. So in terms of things that people can understand, and to explore which areas of application may benefit from quantum computing in the future. So it's also important that we don't only look ahead about 5 to 10 years. So we also want to be able to use the NISQ devices. And here too, we're exploring so what NISQ devices can be used for, because we think, so even if you don't achieve quantum supremacy, or so, for example, be able to simulate electrochemistry or find cathode or anode structures for a battery today, you may be at some point in the future. And this intermediate application, so sometimes when you work on optimization, for example, you may be able, with the NISQ devices, to be a little faster, a little more accurate than with a classical algorithm. And still, it's not supremacy, but for a business, it can mean something. So for example, if you look at traffic flow optimization, if you could be 5-10 minutes faster in redistributing vehicles in the traffic system, that can already have a significant business advantage. So these are the things that we consider to be successes. So even if it's not happening today, we try to identify these applications that have the potential in the near term, but also look further out into the future, scale down our problems, and try to estimate based on what we know today about the devices, about the applications that we work on. So what could be, or where can we achieve most benefit in the future? And then, like Joydeep said, it's about having a team that's ready and that can work with the devices once they're powerful enough to solve industry relevant problems, or to enable us to solve industry relevant problems. So that's really the goal. So generation of IP, you can do that. Then for the others in the audience, so what would also help is if you are able at some point to predict revenue savings. So that can be something where you really look into what can be achieved in the future and try to make that transparent to your senior organization. So I think that's what's really most important for us, to have the team that's ready when the devices are ready, but also generate IP today. We don't generate revenue today. So for my organization at Volkswagen, I have to fund the quantum team with the revenue that the other teams generate. But that's something that's possible because our IT organization is, because we're a big company, it's fairly big. And if you have 10, 15 people at Volkswagen doing quantum computing, then there is ways to fund them. But it may be more difficult for medium-sized companies. I certainly understand. And so I think it's really important is to show what can be achieved in the future and start working on applications today.
All right, thank you. In response to one of the audience questions about a reading list, Jay, thank you for responding in the chat about where people can get started. Let me say YouTube has a tremendous number of very useful videos about about quantum. And of course, there are various books about this. Jay, I want to turn this around for a while. So here we're talking, you are enterprises. We've been talking to people in enterprises about their quantum programs, their expertise. Let's flip this around to people who want to get hired. All right, either by you in the future or by other enterprises. So here, we'll start by talking a little bit in the future, and these are no guarantees. I'm not saying you have job openings listed anywhere or anything like this. Let's talk about the skills that you anticipate bringing into your organization. And let's just 3 time frames over the next year, over the next 3 years, over the next 5 years. And in 5 years, let's assume quantum computers are starting to do things better than just classical computers by themselves, somehow, some way. So let's talk about this. Let's talk about the mix, what you'll be looking for, short, medium, longer term. And also, I want to separate between scientists, engineers, and we'll call them software developers, who of course can be engineers of different sorts. So how's this mix going to change, Jay? And how do you think Boeing will be enlarging your team with these people?
So our chief engineer, Greg Heislip, likes to talk about what he calls the pie-shaped engineer. And I think it's a very good analogy for the kind of person we're trying to look at. So if you think of the skills as the legs of that pie, that the letter pi, it used to be in a career, it was good enough to be deep in one area. And with that depth, you could build up to some point where eventually you broadened out from, use that depth as a means to broaden out into other adjacencies. We're really looking for people who kind of have 2 areas of depth. And so I would say those people who are in the quantum domain, it's not enough to be an expert in quantum. Realistically, in our organization, you need to be an expert in quantum and an expert in something else, whether that something is what that quantum technology will be applied towards. For instance, our people who are quantum physicists have had to learn chemistry, or have had to learn structural engineering, or have had to learn electrical engineering, because it's not enough to do one thing anymore. In this kind of technology development, there is so much interplay between different areas and domains of expertise. We're really looking for people who have kind of a leg in 2 or more of these and a bridge that allows them to span and walk and move amongst those with relative ease. So my focus in hiring is looking for people who have demonstrated skills in 1 or 2 particular areas, quantum technologies, and either electrical or system or mechanical or structural engineering disciplines, and have demonstrated the ability to rapidly take on new challenges. And with that, I'm confident that whichever way we point them, they're going to be able to take that skill base and use what they bring to the table along with the knowledge and expertise of the rest of the team and become an accelerant for that team, as opposed to an anchor that the team has to drag forward.
Okay, thank you. Matt, over to you.
So, I mean, we're just not going to hire quantum people from the outside. We never will. That's just the nature of our business. But what we will do is we'll develop from the inside. And healthcare is a very deep and broad and rich space. So we've got all kinds of spaces that quantum can play in. And I think that's kind of the long and short of it. What I would echo from Jay is that in the healthcare domain, I mean, even if it's an AI, right, you have the same problem. You have sharp technical skills you develop in academia and from experience, and that is exactly 1/2 your education. The other half of your education is domain specific area. You will apply those skills. And when we go from clinical to any other space, or from any other space to clinical or legal or claims or any of those things, those are entirely different domains that are deep and rich, that have their own steep learning curve. And so what we have found is it's sometimes easier to take someone with deep domain experience and then train them in quantum, or train them in AI, or train them in something else. Because if you look at the efficiency of learning in both those spaces, the harder thing to learn is the domain experience. If you're a clinically facing medical practitioner, that's a deeper pocket to learn that's harder than AI, than machine learning, than data science or quantum initially to an extent. And so you need to look at the cost associated with both of those sides. And sometimes it's even tertiary when you get people that fuse 2 or 3 different domains. That situation, no matter if it's quantum or AI, will always exist. And what we've found is that the business expertise, the thing that takes years to develop, is the harder thing. And then we can likely, to an extent, train them in quantum. And then all of a sudden, you've got someone who's really potent in that space. So that's kind of the route we'll look to train our own internal folks. And that's what we've done. I mean, we get people from all walks of healthcare. We've got a large organization that spans lots of different spaces. And we begin to train those folks in those individual areas and kind of go from there. Seems to work.
We use the phrase model developer to talk a little bit about it, a pie-shaped engineer, with the idea that you need at least the 2 areas of expertise. So, well, we don't have financial services represented here, somebody who would classically be called a quant, right? So, who these days probably was a physicist back in earlier life, but that is, they know the algorithms, they know the problems that they're trying to solve, but they also know today high performance computing, right? So they know how to make the most of the computing infrastructure that we have today to advance specifically in their own domain, and they're the ones who are then picking up quantum. And a lot of these will just it won't be specifically quantum. You know, there'll be software developers who, oh, by the way, yes, they know quantum and they know Python and they know this and they know that. So there'll be a little bit less distinction.
In the end, Bob, it's an entire spectrum. You have the people who are heavily quantum and don't need to know as much about the domain expertise. Those people are good for some kinds of projects, for some kinds of research or application development. And you have those who are very deep in the domain expertise and very light on quantum. And those people are good for a different mix and a different kind of project. In the end, you have to work with that entire spectrum, and you need to bring everybody to the right balance and try to hire the people who have the ability to navigate along that balance quite well. And as Matt pointed out, sometimes it's not even a two-dimensional scenario. It's many dimensions that you have to acknowledge, but it's a wide spectrum. And so we're not saying, I don't think that anyone here is saying that the quantum is always the easy thing. Sometimes the quantum is the hard part. Sometimes the domain expertise is the hard part. The hard part for us as leaders, I think, is identifying which is which and finding the people with that match and that skill set and that expertise that we really need, and deploying them towards the problem that matches that set of skills that they bring.
Okay. So I'm going to turn this question now to Florian and Georgia. And by the way, we are getting toward the end here, so I may need to curtail this a little bit. But in your responses, and Florian, let's really focus in on the software developers. So I'm not talking about quantum scientists. Okay. Mm-hmm. What's going to be what does the perfect resume look like, in the next year or in 3 years for someone who thinks of themselves primarily as a software developer who wants to work in your organization?
So I'd say software developer already sounds really good. So we're really not limited to hiring quantum computing scientists or people that have a quantum physics background. What you will notice is, or what you know, is that, I mean, the knowledge of quantum physics for quantum computing is very limited compared to the overall quantum physics world. And anyone with a technical background or anyone with technical interest can get into it, anyone with software engineering background. So if people are curious, if people want to develop and use new technologies, I mean, that's the perfect background already, just being curious and being technical, and that's it, and everyone can learn it.
Julia, software engineers.
Yeah, so software engineer is also a responsibility for Ford IT. Our technical team is more involved with hiring in the quantum domain experts. But overall, I can say that our hiring strategy is based on the gap. So I completely agree with that spectrum that we are talking about here. Sometimes we have a gap more towards domain side. sometimes we have gap more towards the quantum side, and we try to fill the gap when it comes to the point of hiring. But if you try to focus on software, I think I would more concentrate on the domain side, which is like people with background in software development and have the quantum knowledge based on some certifications, right? So that, because end of the day, quantum is a black box when you're talking about the software. End of the day, you have to program it through the SDKs, and people who has that skill set, they should be hired in those teams.
Okay, we are at time, and I think actually your closing remarks were excellent, as were everything else. So thank you to the panelists. I hope those of you who are attendees can see that it really depends on your business, how quantum will play and how you will integrate it into it. It isn't, as I said before, quantum for quantum's sake. You'll be adopting quantum to solve some specific problems. Look around at other companies in your business, see what they are doing. Educate a team, get started, understand where you will get your expertise from. The panelists all, I believe, gave you some really excellent ideas on doing that. There's a lot of material out there. Thousands of people are being trained. You are not alone. And one thing, going back, Jay, I think you said you started 6 years ago, 3 years ago, 4 or 5 years ago. We're well into this quantum era here. We're not on day 2. We're still learning. Yes, the machines are getting more powerful, but there's a lot of information that's out there to start your quantum journey. So with that, gentlemen, thank you very much for joining us, and to the attendees, enjoy the rest of the conference.
Thank you very much.
Thanks, everyone.
Thank you.